There's going to be a little bit of a repeat introduction for those of you who made the first session. I'm Pete Raymond. I'm a biogeochemist at the Yale School of the Environment. I'm also a new co-director of the Yale Center for Natural Carbon Capture. The center was started 4 years ago with a super generous gift from FedEx. It was transformative, and the way that we set up to basically try to look at natural systems and manage lands and try to see how we could manage them differently to remove greenhouse gases from the atmosphere. And the gift has been really transformative because what it did is it freed up a bunch of Yale scholars to sort of broadly study these natural climate solutions and to sort of work across what I'm calling like the natural climate solution ecosystems, to work with a bunch of different stakeholders to try to have impact around natural climate solutions. And really important, when you have this sort of transformative funding, it allowed us to both look at the really big, important questions, but also be nimble enough to sort of approach and try to help when new questions arise. Because what we're all seeing is that this is, a very new field, and problems and questions are arising quickly, and this type of funding allows us to really come in and make an impact and do this from, a fairly neutral vantage point of the university setting. And, we've been reflecting a lot as a group on sort of how we can make impact. And for those of you who heard me speak before, and importantly, saw Sarah Kibbing's talk previously, where she did a really good job of explaining this, is like, as scientists, we are really good at sort of getting in the lab and getting out in the field at sort of the small plot scale, and using all the tools of our trade, sometimes of which are very expensive, to really probe and understand the mechanism of ecosystems. Many of us have been doing this around this sort of ecosystem carbon budget and natural climate solution space for a long time. And so we have a lot of knowledge base on these mechanisms, and we know that these ecosystems can be used to remove greenhouse gases. But what's really needed and where we see we can make an impact is for us to work at the larger scale, and in particular at the scale at which these deployments are occurring, and to bring our science to both learn more at this scale, the scale that we can't do as scientists alone, but also to do things like optimize MRV at this scale so that the cost of MRV can come down, which is an example of a roadblock in this science. And so this second session is going to focus on enhanced weathering and how we can achieve higher integrity, low cost carbon credits through enhanced weathering. It's co-chaired by my colleague Noah Planowski. Many of you, I'm sure, know Noah because he's been, sort of no pun intended, a real force of nature in this natural climate field. He's done a lot and has had a lot of impact on getting this field to where it is. And he's joined by Karen Ellis, who is a force of nature sort of in the corporate sustainability. In fact, was just named a corporate sustainability leader by Forbes. So I think we're in for a really great show. They're going to come up and do sort of like a little fireside chat, and then Noah's going to run a panel around this topic. So let's really give a round of applause to these two pioneers in this field.
Great. Well, thanks, Pete, for that overly kind introduction. And Karen, thank you so much for willing to be here. So I think we'll forego our introductions, given that Pete introduced us, and jump right in. And thanks, everyone, for being here. Yeah, so to start off, one of the things is we've heard about this generous gift from FedEx, which has been transformative for Yale, and I think transformative for many aspects of carbon dioxide removal as well. Maybe to start off, the idea to invest so significantly in research is something that is a bit of a break from how many other corporate entities are engaging in carbon dioxide removal and engaging their sustainability efforts. And that builds a lot from the vision of Brad Smith, but you have been, of course, essential in turning that reality, or turning that vision into a reality. Maybe to start off, could you talk about what is the motivation for FedEx and you for investing in research as well as implementation of climate solutions?
Yeah, thank you, Noah, and thank you guys for finding this topic interesting enough to join us this morning.
Especially in the rain.
Yeah. I definitely want to answer your question by hearkening back to our founder. I know, or I hope that you know our late founder, Fred Smith, and he was just an insightful leader, and I think you know the story. I know it, Noah. I hope many of you know it in the room, that he was such a creative problem solver that back in 1973, it's because of his visionary tactics that we have overnight delivery today, right? And so when you see a FedEx truck outside your office or in your neighborhood, it's connected to an expansive global network of thousands of trucks and hundreds of aircraft that can get almost anything to you in your front door in as little as 24 hours, right? So that is the kind of leader that he was. And that speaks to a belief that FedEx and Fred have as well about the good of aviation, the good that aviation delivers. And we were also at the same time, while we appreciate that, we were open to what climate science was saying. And it was advancing in a way that Fred recognized aviation as being an intractable problem. That was his words, not mine. and so we began to think about the immense pool of researchers and scientists at Yale, and started to think maybe we can begin to solve this problem together. Because when we began to think about what we could do a few years back, we set a goal for using sustainable aviation fuel. I think you guys know about that. It is potential for up to 80% life cycle reduction for aviation. So we are highly excited about that. It is one of the solutions in our toolbox, but its scaling is very slow, and we're not confident that we'll have the volumes that we need when we need them. I read somewhere the other day that it's about 3% of all jet fuel that's used. And even if we were to have all the SAF that we needed, even if we were to upgrade every aircraft that we have to the latest fuel-efficient model, and even if we were to have every truck you see on the road as an EV, we will still have a significant amount of residual emissions. So we needed the type of work that the Yale Center is doing to address those residual emissions. And so that's why we're excited about the center's work. That's why we are amazed that since the investment in research in 2021, in just 4 years, what you have done, you and your colleagues. And that brings me to really a question for you, Noah. I certainly am particularly enamored of one of the CDR technologies. I've made no bones about I am in love with enhanced weathering, so we can talk about that a little bit later. But really, can you remind us of what CDR technologies really are showing, maybe the top 2 or 3 or so, CDR technologies that are showing the most promise from the center standpoint right now? Because again, we're not the only entity that will have residual emissions and need the kind of durable solutions that are coming out of the center.
Well, as I heard Thanks for that. As you heard from this morning, the center works on a really wide range of problems, and really excited about the potential to have transformative steps in forestry sector and land management aspects. And those are things where it's been at a more advanced stage in terms of market activity than some of the more nascent solutions that I work on and that we're really excited about. So for enhanced weathering, Pete kind of introduced, this is one that we're extremely excited about, since it's something that has a potential to tackle two real problems at once. One is you're working with farmers to improve crop yields, improve soil health, while also delivering carbon dioxide. And so it's one of the main benefits from this is you could think of it in terms of a process that's only based on carbon. You're adding rocks to soil that remove carbon. But for most of the folks we interact with, what they really care about, and what is an excitement to me, is that they care about not the carbon side, but how does this improve their yields, their soil? How does this improve the likelihood that they're going to actually make money in a given year? And that is reflected in lots of different ways. We work with smallholder farmers where this is transformative because they don't have the resources to have any soil amendments in some cases. Small amounts of income can be transformative for if they have debt or not. And we also work with some of the largest farmers in the world, where the amount and the impact with the scale that they have can be something that is exciting. We are working with some farmers that have thousands of acres, tens of thousands of acres, where they can implement large amounts of carbon dioxide removal with single decisions very rapidly. It was, I guess, too many points at once, which is how I feel about enhanced weathering. There's too many positive things to talk about.
Yeah. I mean, that's the beauty of it. It's the simplicity, right? You are not only bringing forward a superior carbon removal methodology, but almost regenerating the healthy baseline for part of the food cycle, right? And at the same time, the life-changing economics for those farmers and farming communities is just something you can't ignore. So that's what attracts me to this particular solution.
I think we are getting better at this as well. Often when I talk about enhanced weathering or how I got here, the jokes I usually say is that I'm from the Midwest. My family, I still own a farm with my family there. And the first place we did this was on my sister's farm, and we didn't see any impacts in yields or in soil health for the first couple years, which was really frustrating, to the point where I almost gave up on it. And we later moved to more degraded soils, we got better at trying to decide where enhanced weathering can make a real difference for farmers. And when I reported back to her on that, she loved it. She was like, yeah, I told you, I got the best soil in the world.
Yeah, I think I've seen some of your data that said 10 to 30% increases in crop yields. Is that?
Yeah, and I think that especially we're seeing in tropical soils, even higher impacts. And I think one of the things now is we have the first data that is multiple years as well. It becomes not only anecdotes on how this has transformed soil health, but something that is robust data sets and things we're hoping to move into publications as time goes on as well.
So not just in the Midwest of the States, but in the global South, some of the soil is so degraded that we're seeing some extraordinary results right away.
Yeah, it's you always have to be careful as a Midwesterner making fun of Southerners for their soil, but it's
Watch out, I'm from Memphis.
it's an easy point to make. I think in general, when we think about the soils that are going to be most responsive in terms of delivering large amounts of carbon dioxide removal and having a real impact for farmers, areas in the tropics and in areas like the southeastern portion of the U.S. really jump out.
Can you unpack a little bit more about the availability of this natural resource to catalyze this kind of change? Because we're not talking about pulverized rock that's only available in certain areas of the world. Can you unpack that a little bit? Because that speaks to the multiplier effect that's possible with this solution.
Yeah, great question. So we mine tens of billions of tons of rock a year, which is a difficult number too. As humans, we often struggle to think about numbers that are that large, what that means in terms of scale. Another way that I think is easier to think about it is, given that we have such extensive mining in general, there is in large portions of the world, there's a quarry or a mine that is within 200 kilometers of any point. So it's something that this is mining, which is we're utilizing aspects from quarrying and mining is not isolated. It's a ubiquitous part of civilization. And obviously most of it is used for cements and roads and buildings, but the waste products of that can be better utilized and tie into carbon management.
So, I feel like I'm interviewing you. So, tell us really, for those who are not familiar with enhanced weathering, just a layman's version of it. So I don't want you to put your professor hat on, but I want you to give us kind of the science behind why it works.
Yeah. Well, I think as my teaching evaluations will say, I'm not known for brevity or clarity. So I think you'd probably actually do a better job at that question than me at this point. But I think the simple idea I think of it from enhanced weathering is that there's these rocks that are ubiquitous across Earth's surface that will react with CO2 that's coming from plant roots, and it'll transfer it into a stable form in waters. So this is actually why Earth is habitable. This is the main way in which Earth regulates its natural climate. What we're really doing is just trying to speed up what Earth does naturally in drawing CO2 out of the atmosphere and storing it in the long term in the oceans.
So let's talk about the elephant in the room. For us, I talked about sustainable aviation fuel earlier. And not only is it not scaling fast enough, but there's also work to be done around the cost of it. We as airlines or the aviation community want to use more of that product. But the cost is still challenging, and we need to make sure that when you push that button for free shipping, that we can afford to deliver on that. So to make sure that air transportation continues to be affordable, we also need the cost of SAF to come down as well. So similarly, with the CDR technologies, or specifically enhanced weathering, the MRV still has some challenges on the cost side. So let's talk about that a little bit.
Yeah. So I think one of the things that we're obsessed with in a center, and that Sarah did a great job of highlighting as well, is thinking about how we can have costs of MRV come down while not sacrificing quality and certainty. And I think part of that Sarah did a much better job of highlighting than me is that developing frameworks for how your certainty or your uncertainty scales with project size is an essential aspect of having costs come down. I think the vaccine analogy that Sarah uses is one that we really like. So obviously, it's been really hard to have the CDC dismantled, because that's our favorite metaphor. But we don't have another one. We're sticking with the vaccine, which hopefully we're doing as a civilization as well. So we think that's a big part of the cost coming down. But enhanced weathering, one of the things that we're also obsessed with is finding areas where the co-benefits of this are so great to farmers that it can really have the cost come down. So to go back to where I started, it didn't make, when I did this on my sister's farm, where I wasn't doing that because that was the best place to do weathering. I was doing it because she's the only one that would let me spread rocks on her field. That didn't pan out economically. We've gotten better at figuring out where we can do this. And if you have large benefits, that's going to directly reflect the costs. And the research center has allowed us to get much better at that job. We still have a ways to go. We're still working on coming down the cost curve, but I think reframing MRV, developing new tools for MRV, but also just making sure we're doing projects in places that make sense, which is something Sarah did a great job of stressing as well, is an essential aspect of carbon dioxide removal that works. And by works, I mean something where you look at the price tag and you you say, all right, that's maybe all right.
Yeah. And one of the speakers earlier said we should shift our language from co-benefits to co-drivers. I like that. I think I'm going to have to steal that from him. So with these co-drivers that I certainly am looking for the glide path to get from what is probably about $300 a ton for these credible carbon credits to something far south of $100. And so I think I want to unpack that just a little bit more, and I think I want to talk about getting out of our echo chamber, because I think what will attract more diverse funding sources, what will attract more buyers, particularly corporate buyers, is to renew and restore the trust that carbon is actually being removed. So can you talk about how do you think, from your perspective or the center's perspective, how do we get out of our circle of believers and convince the global community that this is a real solution that they should consider?
Yeah, good question. And one that's the narrative and the kind of societal perception is an essential aspect of carbon dioxide removal. I think as an academic, one of the things that stands out to me in this is, for a while, when you look at historically how academics interacted with the carbon dioxide removal market, in many cases they viewed it as a policing practice. So action would be occurring, academics evaluated that after it occurred. One of the things that is an essential aspect of how we founded the center, the vision that Pete and directors are trying to carry out, is ensuring that we're helping, and that Sarah did a great job of talking about, that we're trying to help build something that is addressing concerns that have been raised in the past instead of just evaluating activity after it's done. And it's not going to scale without everybody doing that, but I think making sure that you have academics working with academics and NGOs, working with corporate entities, with suppliers, and with people that are doing the evaluation, instead of one of those legs being removed and just evaluating, I think is an essential part of moving to a much better space. But I think part of it is also just the framing from this. We know that some of these solutions, we too often move to a narrative where enhanced weathering doesn't work. Well, what does that really mean? There are areas that have higher uncertainty, but we know that it's removing carbon from that. Thinking about how we frame these things instead of it doesn't work or it works, but thinking about how we can have robust estimates of uncertainty at scale is I think, an essential aspect of moving forward, building trust.
I think that's a really good point, because the carbon market itself is doing a course correction, and we need to be comfortable, just like any other market or any other system, that course correction is necessary at some time, right? And we learn and we move forward and we apply those lessons learned. I know one of the positive outcomes that I'm expecting from the center's work is that regulators and international standard-setting organizations, again, accept the science, accept the facts that carbon removal is actually happening, and so that the frameworks that they are responsible for will allow for a balance between incentivizing decarbonization, the actions to decarbonize your own operations. We're doing that. We have a goal of carbon neutrality by 2040 in our global operations. We can do that and incorporate these CDR technologies, but some of the frameworks don't treat CDR possibilities or CDR solutions in an equitable way. I think some tend to think it's either or that we need to relegate the use of these CDR technologies to a sliver of the footprint or to a future time once all of these course corrections in the market have occurred. And I don't think we have time for that. We need all the solutions available to us right now to address excess carbon. How does the center feel about the use of or the considerations of how CDR technologies are being used?
Well, that's a potentially, I could get myself in some hot water on that one. So I'm gonna respond for how I feel about that, and let Pete handle how the center feels about that maybe. But I think one of the things that Ken say that I don't think is controversial on that is, in many cases, making sure that as we're developing those policies, that we have the best available information available for decision makers. So making sure that as decisions are being made, that it's based on a wide range of views that are representative and that provide, I think, the most accurate look at carbon dioxide removal instead of something that is based on outdated information or based on very skewed by cases where there were clear failures in carbon markets previously.
Yeah, for some reason we've gotten to the point where because there's a failure or two, we want to throw the whole thing out, and that's just not acceptable. That's not science, right? That's not how we do it. I heard a quote from Celine Cousteau this week where she said, let me read it, profitability without sustainability has no future, and sustainability without profitability has no impact. And so we have to solve this problem, whether we're talking about SAF and the cost of it, whether we're talking about the cost of MRV, whether we're talking about the acceptance of these solutions in all frameworks, mandatory and voluntary. We have to solve this solution because we need all of these applications working together to solve the problem that we're sharing here. And so I have, as we wrap this up, I have full faith in the work that the center is doing. I believe that you will leverage the benefits, the really rich benefits that nature offers to help us protect it, to help us meet our climate goals, but also to help companies like ours continue to deliver the global service that our society has come to depend on and has been life-changing in so many communities around the world. So I want to personally thank you on behalf of the 500,000 team members at FedEx for all the work and the success that the Yale Center has seen over the last 4 years, and we have great optimism for what's to come.
Well, thank you so much, Karen. And as we wrap up your last one, for last question over to you is, as you really loved and just wanted to draw on one point that you made, the idea of trying to have carbon dioxide removal as not be viewed as an alternative, but something that could be incentivized with decarbonization, efficiency improvements from that. As a kind of closing remark from that, maybe of how do you see FedEx utilizing carbon dioxide removal forward, and love that vision, how do you see that being implemented as best as possible, and how can academic centers and all of the people excited about carbon dioxide removal in this room help you carry out that vision?
Yeah, I don't want to repeat it specifically, but we have to have a business case for it. So we have to have rewards along the way. So our journey is to 2040 to be carbon neutral. And I said before, we're focusing on decarbonizing our operations every step of the way. We've been doing that for almost 20 years. For over the next decade, we have clear plans that we've talked about publicly as well. But again, as I said a few minutes ago, we will have residual emissions. And so when we are joining coalitions, when we are making science-based commitments, we need to be able to use all solutions available to us. So what the community can do is, in your circles of influence, if you are able to comment on evolving standards, if you're able to comment on regulatory actions, make sure that these viable solutions that are helping us to solve the problem can be included in those frameworks, because that's the business case for us to begin using them sooner rather than later. Otherwise, when you relegate them to a future use, the markets are unlike, these are nascent markets, right? So they're unlikely to be able to deliver the volumes and the credible credits that we need when we need them in the future, because they need to be nurtured, those markets, those projects, the ideas, the confidence in the science needs to be nurtured now in order to be a viable solution in the future. So what I would say is that if you're in this room and you have a voice in this space, make sure that the science is understood by those decision makers, that you have decision useful information flowing to them, and that these frameworks recognize that this is a real solution that should be a part of the outcome.
Well, thank you, Karen, so much for taking time to be with us and for your incredible leadership. So we're going to transition to the next portion of the panel, but wanted to take time if anybody had a burning question for Karen before we transition. In the back, yes? We can actually shuttle a microphone to you quick.
So I have a thank you so much. My wife has a small business and uses FedEx and loves it. And whenever she ships one of her products to a customer, she goes online and the dimension of the package and the weight of the package determines the cost of delivering it to whatever destination. Does FedEx, for its business customers, account for the greenhouse emissions that are involved across the board for all of their packages that are delivered through you in a way that could enable them to actually contribute to the emissions reduction, so that it's not borne entirely by FedEx, but to use a different analogy, it could be part of the destination charge for a vehicle that's shipped from Japan to Africa, for example. And is there any scenario in which you could see in the future that might be extended to the individual consumer as well?
Thank you for the question. We absolutely provide very detailed reporting to our customers around the emissions related to the service that we provide them. So the report shares with them how much was from flight, how much was from truck, and the way we do that on the back end is all of that information that you just mentioned that your wife has to give us when we're shipping it. We're looking at the weight, we're looking at the transport mode, we're looking at that particular origin and destination. How many flights did it take, or did it take 2 trucks and a pickup and delivery at the end? So we absolutely have that data. We do have an offset program. The uptake of it has been moderate. And I think, again, I will be transparent and say that most of our business customers who want to offset their emissions based on our service, they take our report, they have confidence in the data, and they go offset those emissions themselves. The medium to smaller customer has the option to enroll in our offsetting program, but again, in this day and age, people want free shipping. They don't want to necessarily add cost to that, especially with all the import and export changes that we are trying to adjust to. So we have it. Our larger business customers really are sophisticated enough to do it themselves. So.
Great. I think we're actually, to keep on time, we're going to transition to the next portion of the panel, sorry. But let's thank Karen again. All right, we're going to welcome to the stage Toby Bryce, who's the Managing Director of YCNCC, and will be chairing the next portion here.
Thank you, Noah. Great to see everyone here. Thank you so much for joining us. And we have 2 panelists right there. Come on up, come on up. Come on down and join us, Noah. One more. Excellent. Yeah, so I'm the managing director, Toby Bryce, managing director of the Yale Center for Natural Carbon Capture. Thank you all for being here with us this morning. It's been a great program so far. Thank you to Sarah for convening the first session and Noah for the second session, and especially to our friend and colleague Karen Ellis for such a great conversation. We're going to dig right into it. We have two Yale grads here who work on enhanced weathering and geochemical CDR, who lead companies. And just to kick off, maybe you guys could introduce yourselves and talk a little bit about what your companies do, and we'll go from there. But Mary, do you want to go ahead?
Hi, everyone. Thanks so much for joining us today. I'm the co-founder and CEO of Lithos Carbon. We are an enhanced rock weathering company. A lot of y'all have just heard a good amount about enhanced rock weathering. We spread waste byproduct volcanic rocks called basalt in 10 different states in America, and we are scaling technology that was initially developed at Yale. So we are really, really proud to be taking the baton, running with it, and learning what real-world deployment looks like at scale. As you deploy more acres, as you deploy more diverse farms, you really learn so much about what it looks like to do this deployment in the real world, what geochemical traits really matter. So excited to share a little bit about that today, and really grateful to the center and to FedEx and to all of the folks who've been powering this innovation and learning so that we can really figure out how to scale permanent carbon removal.
Thanks, Toby. Hey everyone, my name is Joe Kachanoff. I am the co-founder and CEO of Crew Carbon. I'm also, Mary, a Yalie. I did my PhD and postdoc at Yale, where we developed a lot of the research that underpins Crew's technology today. So at Crew, we use globally abundant, naturally occurring minerals, predominantly limestone, to make wastewater treatment more efficient and cost-effective, all while capturing greenhouse gases. So effectively, we have this dual solution that we can sell to utilities to increase their efficiency and lower their operating costs, while at the same time, we're generating these highly measurable, highly durable carbon credits, which we can sell to the carbon markets, so large corporates or government entities. And effectively, the technology we deploy takes wastewater treatment facilities, which are a well-known cost center, and actually flips the script. So we are able to turn these facilities into revenue-generating hubs.
That's great. Thank you both very much. So I think it's fair to say that Yale has been instrumental in advancing enhanced weathering and other forms of geochemical CDR. Noah, you've talked about a little bit of this with Karen, but what do you think primarily differentiates these CDR pathways from other CDR pathways? And then within geochemical CDR, like how should we think about the different approaches?
Yeah, great question. I like to think that Yale has been a leader in implementing geochemical carbon dioxide removal, in part to start with that and what differentiates it, by trying to think about what are the co-drivers of these systems. So, I think there's lots of forms of geochemical carbon dioxide removal that stand out by having really high durability. We're going to need to meet our climate goals a wide range of solutions. Those, without question, are going to have to include land management-based shifts, but there's also a need to have highly durable carbon dioxide removal credits and geochemical aspects from that. When we think about geochemical forms, if you think about this as direct air capture, potentially forms of ocean carbon storage, not all of those processes are going to provide the same benefits to communities. It will be focused on the same ideas. We're transferring atmospheric CO2 through geochemical reactions into a permanent reservoir, and what makes these pathways stand out. But only some of those will be delivering real impacts to farmers, like Mary is, to wastewater treatment plants that's reducing pollution, like Joe's doing. I think focusing on those aspects has been a key part of what the center has been motivated to do, and I think that's an aspect that is distinguishing what we should focus on at a very early stage for implementation for geochemical carbon dioxide removal versus things that could become more important later in later decades.
That was great. And I do I'm also going to steal the co-drivers. What, Joe and Mary, so what So co-benefits, nice to have. It's great to have benefits, and it's good to help farmers. But can we talk about like how do these things become co-drivers? Like what do co-benefits do to enable scale, and how do they help your actual businesses? Joe, why don't you go first?
Yeah, happy to. So I sort of mentioned, and Toby is okay, I'm going to give a quick overview of what wastewater treatment looks like so everyone knows what that is. Effectively, every single day we're producing billions of gallons of waste from our homes and businesses, which are being channelized and taken to wastewater treatment facilities so that operators can remove pollutants, create clean water, and discharge that back to the environment. It turns out modern wastewater treatment actually produces huge amounts of greenhouse gases. Depending on who you ask, the sort of estimates are 2 to 5% of global greenhouse gas emissions comes from the wastewater treatment process. That's huge, right? Like that's equivalent to, or similar to aviation, shipping, and that's all happening in infrastructure that exists already in our backyards. And so now if we step through the process, right, all that waste is going to effectively like football field long concrete tanks where operators grow trillions of little microbes, bugs, in these concrete tanks to eat up and remove those pollutants. One of the key ones is carbon. And so they take that solid carbon that's in our waste, industrial waste, and turn it into CO2. And you end up getting this really concentrated form of CO2 within the wastewater reactors, 100 times more potent than what you have in the atmosphere. So a really good opportunity, as you guys can imagine, to then implement a technology to scrub away that CO2 in a closed, engineered, highly measurable system that is pre-permitting and has existed. So that's sort of one aspect of our solution. But Toby, to your question about sort of what is the other lever that we pull on to get this accepted and scalable is really tying this technology into what the wastewater operators are doing. They're using these bugs to do their process, and the bugs don't like CO2. They work less effectively under acidic conditions, which means more pollutants are leaving the plants and hurting our environment. And in the business case, that actually comes at a cost. So the dual solution, right, by helping the wastewater operators run their process more efficiently, removing pollutants more effectively, reducing the amount of chemical inputs they need to procure and use, ultimately ends up to a better treatment process, which keeps us safe, a cheaper process, which reduces the tax burden on American ratepayers, and that's really one of the key drivers that we tap into. We often don't talk about carbon removal as like the major focus when we engage with utilities. It's usually like, that's actually the co-benefit or the co-driver when we talk to the space. I'm sure it's similar for you, Mary. And so we first lead with the fact that we can improve their process. Oh, and by the way, the cherry on top is removing carbon dioxide.
Mm-hmm. Yeah, so in our process, we also piggyback off of existing infrastructure that's really critical. We know that agriculture is responsible for about 25% of the world's emissions. That's pretty wild. That's really high. We're not robots yet, despite GPT and Chatty. And we need to eat, and we need to feed a growing population, hopefully without ballooning that amount of emissions that we're also creating. So a great thing that our form of enhanced rock weathering does is by applying these crushed up, naturally occurring volcanic forms of rock dust, we are decarbonizing agriculture. We're actually replacing other forms of inputs that farmers use. We're replenishing nutrients back into the fields. The rock dust that we use is called basalt. And for those of you guys who might not know what basalt is that dark black volcanic rock you see in Hawaii or in Iceland. Some geologists might call it a mother rock because it is the bedrock for some of the most fertile soils in the world. Lush jungles, the Amazon rainforest, that's like ancient basalt rock. And so by adding this back into the fields, we often lead with that. We're actually just replenishing, rebuilding the topsoil for farmers who are having really acidic, stripped nutrient lands and are trying to grow more and more crops in lands that are just getting, in some ways, less efficient, except for the advent of modern agricultural technology. So that's actually what we lead with. Some of the research that the center has published has shown that there have been over 10% crop yield improvements just by applying this basalt in these stripped nutrient lands. So that's one of the things that's really important for farmers. Part of my family are actually also farmers in Taiwan, so a little different from America. But farmers are actually a very naturally skeptical bunch. They don't really want to adopt a brand new practice unless they're sure this will definitely work for their fields and won't bring any harm. And so I think a lot of the research, the decades of research that Yale has poured into making sure this is safe before you go and deploy in the wild, making sure that you've tried a lot of different things and you've tested a lot of different functions before you go deploy this in the wild, that's been so critical so that farmers, these key community members, whom without them, this process will never scale. They know that this is safe. They know that this will be actually good and beneficial for their lands. And so that's one of the benefits that we care very deeply about and that I care deeply about, given my family roots. The second co-benefit that I want to speak to a little bit is not just the carbon side, is actually for the quarries. We use a waste byproduct in all of our processes today. We've moved over 500,000 tons of it. And to give you a sense of things, some of the quarries that we work with have tens of millions of tons of waste dust that they don't sell. To give you a sense of scale, one of these is the size of 4 Empire State Buildings. Since we're in the great state of New York, that's massive. And it's just sitting there in a pile, doing nothing. Nobody is buying it. It's an eyesore. The residents don't love it. And on top of that, that stuff is full of nutrients and can actually capture carbon. So some of our quarries have told us that if we could move those tens of millions of tons of waste byproduct, they actually could be quarrying in those spots for 10 to 15 years longer instead of opening yet another new quarry next door. That's also beneficial for the community. So from every single step, from creating new jobs in the community, helping the quarries out with their waste process, making a circular economy that benefits the farmers, those are some of the co-benefits that we see as driving this forward and making this make a lot of sense while we're also working to clean the air for the whole global community.
That was great from you both, thank you. And from a co-benefit perspective, sure, nice to have, but we do think the center strongly prioritizes solutions, mitigation solutions that deliver meaningful co-drivers, co-benefits. And if you think about forests, soils, enhanced weathering, marine CDR, which mitigates ocean acidification locally, these are all delivering benefits, and these benefits have value to communities, to ecosystems, and I think there's a limit to how much taxpayers and governments are going to pay just for the carbon benefits. So we think that these co-drivers and co-benefits are going to be essential to achieving the socio-political license that is going to be necessary to scale carbon removal to the levels that we need to mitigate climate change. So co-benefits are super important. I'm going to go off script slightly, but I think we can all handle it. The other thing to me that differentiates geochemical CDR from some other CDR pathways is its deployability. The opportunity to plug into existing infrastructure, the fact that we have these feedstocks available at gigaton scale without having to open new mines. If you think about a direct air capture system, we're building all that from scratch, and I think we're going to need those in the 2050 timeframe, but it's going to take time to build out those solutions. Noah, can you talk a little bit about just sort of the sort of immediate term deployability and scale potential that gets you excited about these pathways?
Yeah, absolutely. So I mean, I'll steal maybe a number from that Joe would use, but as a sense of the scale and the investment that we put in infrastructure that we can tie to carbon dioxide removal, in wastewater treatment plants, we've invested over the last couple decades $2 trillion in the US. So we've put $2 trillion into pipes and containerized systems to create CO2. We move carbon into an area where we release lots of CO2 to the atmosphere. That seems like a pretty good opportunity to utilize that massive investment that US taxpayers put in to drive carbon dioxide removal. From a farm perspective, have to be careful how I talk about this because I don't mean to tractor shame people, but for folks that haven't been on a farm, the sheer power of current tractors is something that should not be minimized. The ability to move material, which is carbon dioxide removal, is moving mass. Having farmers that have invested millions of dollars into the ability to spread amendments on their land is again tying into this massive capital investment that is at no extra cost for carbon dioxide removal. And I think that's what allows us to achieve real scale in many of these pathways on a relatively short time scale. And I think it's those similar benefits also do, I would stress, tie into and should be viewed as complementary to other aspects like increasing soil organic carbon storage in the system and as well.
That's great. Anything either of you would want to say on that topic?
Yeah, maybe just to piggyback off that, just listening to the last panel talking about the future price and costs of carbon dioxide removal, and I think we all agree that we want to drive that to as low of a cost as possible. I think one of the ways that folks are thinking about carbon dioxide removal by embedding it into existing infrastructure is to effectively enable that, right? If you have to build something from scratch, Toby, as you're saying, that's typically going to be expensive, and you're going to have to think about return on that investment. Whereas if we can look around at our environment and maybe be a bit thoughtful about how we can build these types of technologies and leverage them, that's a nice way to come down that cost curve and get us to that point where carbon removal is at or under $100 a ton.
To talk a little bit of brass tacks here, something that I often hear from policy folks, from folks who are financiers in the market, is that they have heard from backroom conversations that a lot of the cap and trade policies, a lot of the border adjustment mechanisms, a lot of the policies that this entire room, that so many of us are hoping will go in to bring government action to the door, might actually be delayed simply because there isn't supply to meet the demand. How can you regulate a market and say, FedEx and all these other companies should try to buy some carbon removal when there isn't carbon removal for them to buy? That's topsy-turvy, that won't work. And so I think to the Yale Center for Natural Carbon Capture's, YCNCC's credit, to the center's credit, I think that this dedicated effort to things that are scalable now, that are rigorous and supported by real MRV, real methodologies, like we know they're doing no harm and they're actually capturing carbon in measurable, high-precision ways today. I think the investment in figuring out how this works in natural systems, how this works in open systems is massive. Because if there is not supply to meet the demand, all of the forms of carbon removal, including direct air capture and these things that require a lot of capital, will be held up because there's simply nothing for the market to answer the call with. So that was a quick tactical brass tacks thing that I wanted to say. It's really, really important that we invest ahead of the curve and also invest in the things that, although they might look less technologically heavy than a direct air capture facility, have so much potential. Some models have shown that enhanced rock weathering can capture gigatons of carbon from the atmosphere a year. That's incredible. Society emits 50 to 60 gigatons a year, so we really, really need to catch up. And the fact that the Earth already knows how to capture over 1 billion tons using natural volcanic rocks and natural silicate weathering, that's wild. We just need to take what nature already knows how to do, scale it up 100,000 times. The materials are already there. The tractors, as Noah lovingly said, they already exist. Farmers love them. We can spread stuff tomorrow. Let's get the measurements really, really good in place. Let's find the best places in the world to do this, and then let's get after it, and it will help everyone. So I'm really excited about the center's commitment to investing ahead of that curve and making that promise possible.
Excellent, yeah. So the session, these two sessions we've titled them Research Through Deployment. Pete has done a great job framing them. Sarah really explored this concept with reforestation and forest carbon. The fact of the matter is that there are things that we don't know yet that we need to find out. We don't have time to wait. We need to start scaling these solutions now, funding them. We need to be able to address uncertainty. There are things about geochemical CDR that both of your companies work on that we don't know yet, and we need to learn by doing. And we can't let uncertainty hold us up. So I would love to dig in a little bit. And both of you, you started your research journeys at Yale University working with NOAA. So that's super exciting. And can you talk about, and your companies both continue to collaborate with Yale and the Yale Center for Natural Carbon Capture on research. So I would love to hear, maybe Mary, you could start, just like how do you think about research in conjunction with your core commercial function? How do you incorporate it? Maybe give an example of something that Lithos is working on with Yale that is advancing research that also fits into your commercial operations.
Absolutely. So something that's so critical to us in our ethos at Lithos is that you make what you measure. So on every single farm we've ever deployed, we sample very densely, like every 2.5 acres, multiple times a year to generate as much data as possible so that we can ascertain that we're making a positive benefit to the soils, the nutrients, to the community, and also the carbon budget in the atmosphere. So that's really critical to us. Although we do this on a commercial sense, and we sample everything we do in the tens of thousands of acres we've deployed so far, there's another aspect of it, which is that every ecosystem is slightly different. Every watershed is slightly different. There are different geochemical settings in different soils. We've seen live over the last 3 years at Lithos that when you apply the exact same basalt A to 10 different farms with different soils, you might see different results. And that's just natural. That's meant to happen in the same way that you apply the same seeds in different farms and you get different crop yields, right? So that's totally normal. So one of the things that we're really excited about is that Yale has partnered with us in constraining ecosystem uncertainties. Not to get too much into science jargon and technical things here, but one of our exciting projects is a state-of-the-art facility, I call it a Sentinel site, in our southeastern hub, where we've installed gas towers, big monitors. We have water monitors going on to understand the influence on the watershed and like the amount of bicarbonate or captured permanent carbon that we're exporting from the system. We are doing work ahead of the curve to really understand how we're impacting the ecosystem and how you can measure this from multiple ways and be really certain, as Noah and Karen said in their earlier talk, that we are doing the benefits that we say we're doing. And that level of certainty is so critical for this market to really scale. We definitely are not going to do gas towers and water monitors on, 5 billion acres across the world. That's a lot. That's a lot of money into gas towers. But doing this really carefully and critically in the early days is so important. So we're really grateful for the Yale's dedication and rigor in this in this way. It's much better, in our opinion, for us to partner with academics who are unbiased, who are independent thinkers, who have state-of-the-art tools and ways of analysis, for them to independently analyze the projects we're doing and to build that trust in the market. So very grateful for working with YCNCC there.
Thanks, Mary. Yeah, there's a couple ways that we've collaborated. Obviously, I mentioned I've completed my PhD and then my postdoctoral research at Yale. And that's during that time, that's where we developed the IP that we utilize at Crew. So one of the obvious ways is generating patents and then licensing them from the university, which is what we do. So that's one way we've collaborated with both Yale, YCNCC, Yale Ventures. And then going forward, we continue, similar to what Mary was saying, continue to evaluate in parallel the impact of our approach, and making sure that we are constraining the carbon dioxide removal that we enable as well as we can, and also evaluate the other co-benefits or co-drivers that are also now come associated with our technology. So one of the ones that I'd call out right away is we're engaging with YCNCC in both lab scale but also field scale trials and experiments. One of the big focus areas that we're collaborating with Noah and Pete Raymond on is the impact of our technology on nitrous oxide production during wastewater treatment. So I mentioned earlier 2 to 5% global greenhouse gases from wastewater treatment. One of the big contributors to that number is the production of N2O from the biological, the microbial treatment process. Those little bugs, they also like to kick off nitrous oxide under unfavorable conditions. And nitrous oxide, as we know, is 300 times more potent than CO2. And so what we're evaluating is seeing if by adding this alkaline mineral to these wastewater reactors, we can actually measure a reduction in nitrous oxide. We have some initial data points that indicates we can, but that's research that independent researchers and well-resourced researchers at YCC can help push forward probably faster than we can. And so we're working on that in parallel with the center and with the university.
Excellent. It's super exciting to see these things happening, and they're happening every day. There's students in this room who work on these deployments, who work on deployments near Clarksville, Virginia, at Crew's wastewater treatment plants where they're co-deploying. So it's really become part of, I think, the center's ethos. We understand that climate mitigation is a massive problem, and science alone is not going to solve it. Industry alone is not going to solve it. So we do need these collaborations. Noah, how do you think about them just from your students are working on these things, you're a scientist. Like, how do you marry science and engagement with industry?
Yeah. Great question. I think, so one of as an academic, you spend a lot of time writing papers, and I'm not sure many people are reading them. So I think about that quite a bit. And I want to make sure that the ideas that you have, the work that we do, actually gets out into the world. And want to make sure that we're able to actually tie into things that are scaling. Universities could never deploy over tens of thousands of acres. The only way we can help move forward our understanding of things at that scale is to work with companies. We're never going to be able to set up large-scale deployments at wastewater treatment plants. And so I think the benefit to researchers of being able to tie into companies who are willing to be transparent, willing to enable research is pretty obvious. And I think the benefit that we have from I think it's a two-way, both parties benefit from this. I think margins for any company are designed to be terrible. So a lot of things that are really good, obvious questions to tackle, companies aren't going to have the margins to be able to get after them. So there's being able to open up deployments for research is something we're passionate about, and I think is going to be an easy way to move forward our understanding and our ability to do carbon dioxide removal more quickly.
I'm going to ask an indelicate question, but I think it's an important question to think about and an important question to ask in this room. We're unfortunately in a moment here in the U.S. where the U.S. federal government is in a, let's call it a declining support for science, certainly declining support for climate mitigation, climate science. How do we pay for this? Like, how do we fund these activities? We are fortunate to be in a position at YCNCC where we have this amazing transformative gift that we received from FedEx, and that money is being put to work with faculty lines, postdoc programs, workshop programs, but no one is sitting on a large pot of money to fund research. And startups, you think venture capital, they have a lot of money, but as Noah referenced and as Karen, I think, illustrated really well as well, it's not a super high margin business. So like, how do we fund this learning that is essential to scale the work that we're doing?
Yeah, well, I think one of the things that is potentially going to be a transformative aspect as we move to, realistically, over the next several years, there will be much less federal funding. Instead of having academics doing their own trials, focusing on large-scale university-only efforts, I think research is going to have to be more directly coupled with industry. It's going to be something where, and the positive from that could be that we actually move to something that does become more impactful. Hopefully blue sky science isn't lost in that process. That would be something that'd be tragic. But in that, and what I think is going to be essential for filling the gaps is small philanthropic donations can make a big impact if you're able to tie into something that is a large scale project. So better using our money and ensuring that philanthropic dollars are going into tackling key problems that aren't going to be solved by the private sector alone is a way I imagine going forward. Having lost almost all of my research funds from the federal government.
I maybe would love to leave some time for questions, and just to before we close, I don't want to close on a pessimistic note. We are in a challenging situation here in the U.S. certainly, and globally with respect to climate change. I'm super grateful that every day I get to go to work and work on something that has impact and is meaningful, and I think everyone on stage feels the same way. It kind of helps me because I don't know what I can do about the larger situation, but I do see that, we can advance this collaboration with Lithos in Southside Virginia, or we're decarbonizing wastewater. And these are things that are possible, and they're happening now. They're driven by research from Yale, and so it's great to be a part of that. So I'd like to close on, maybe just go down the stage, something that you're working on now that you're excited about and that just gives you hope.
My favorite thing in general is just talking to farmers. I love the science. I love working with the quarries. We love our team. And we've got like a great team of about 50 folks who are cranking every single day at like first of a kind data that's coming in the door. But I love talking to farmers. I think it's really, really meaningful to just get out of the lab or get out of your office and really see what's going out in the world, not just America, but other parts of the world where the farmers are honestly really struggling. So that's not my favorite part. They are seeing torrential hurricanes. We had in one of our hubs the worst hurricane or the worst drought in 130 years hit them. And then after that, a hurricane rolled into North Carolina farther west than had ever happened in history. So that was a double whammy. The reason I say that I love talking to the real people out there is because you really see what climate is doing to those on the front lines. And although that might be far away from our steps at New Haven or in Brooklyn or wherever it is actually here. I see this with my family as well. I see this when I visit rice farmers in Indonesia. It is actually just so real. So although I would say that one's a little bittersweet, I'm excited to keep engaging with farmers to say, hey, there's stuff that can help improve the economics of what you're trying to do, even though margins are getting even slimmer for farmers every day, even though the prices of soybeans have gone crazy in America because of political reasons and they cannot seem to export to the places they normally do. All of these things are at their front door. A lot of them are climate driven. There's this chart that I've once seen, which was like the wane and wax of civilizations depending on droughts and climatic changes in the broader ecosystem and sphere. And I think about that a lot. I think about the fact that even if we seem sheltered from it, we are going to experience that at some point, and our kids will too. So I love talking to the farmers. I love saying, hey, we've got some stuff that can help your farms. It makes an impact to them this year. And some of our farmers this year, the capital that they got from lithos and the improved crop yields too actually helped them keep their homes. They actually would have lost their homes and their mortgages because it was such a hard year for them. So I'm really passionate about that. I'm hopeful that more stories like that will come out of the great work that YCNCC is doing to prove these things to be safe and efficient and meaningful for farmers, communities, and our atmosphere. And that's what I'm most excited about, doing more of this, learning more with every single step, getting more data with every single farm we work with, and helping more real folks who are powering the foundation of our economy.
Yeah, one of the things I'm positive about is very recent for me, or upcoming, I should say. Next week, I am heading to offtake, which is North America's largest wastewater conference. 20,000 wastewater professionals will be there. You guys probably didn't even know that 20,000 wastewater professionals even existed, but they will all be there. And one of the growing sessions that we've seen over the last few years that didn't exist a few years ago when we went is dedicated sessions to decarbonization and resiliency within wastewater treatment infrastructure. They're holding now it's the third or the fourth annual session dedicated purely towards decarbonizing wastewater infrastructure, which is really great to see. And that's North American utilities. They're more and more committing towards accepting climate goals and putting technologies and steps in place to actually enabling them to decarbonize and reduce their own carbon footprints. So that's something I'm incredibly excited about. When you step outside of North America, the interest in decarbonization across the globe continues to push forward, and we have more and more incomings every single day from utilities abroad that really understand the potential here and the potential to make positive climate impact.
Bring us home, Noah.
Well, just to wrap it up, one of the nice things about academic centers is that you're surrounded by a wide range of people with very different backgrounds. One of the things I've been very excited about is the colleagues that know a lot more about forest management and land management have opened me up to the potential for mangrove restoration, something we're really excited about. And one of the aspects from that we're working at that we're working at the center right now is the ability for mangroves to produce permanent carbon removal through alkalinity generation. So the same processes that we were talking about, but driven by mangrove restoration. And things that are really fun is learning. So I know a lot about alkalinity, I know a lot about geochemistry, and I know much less about mangroves. So I'm really excited about being at a place where I can learn about forest practices and learn about mangroves and tie that into something I do know something about, which is alkalinity.
So after this, ask us about mangroves, wastewater treatment, farmers, enhanced weathering. But we're going to open it up to a few questions, and not to embarrass her, but Ella Milliken, who is going to be passing the mic, is one of Noah's graduate students, and she is leading the deployment with lithos carbon. So afterwards, you can ask her about manure, chicken litter, nitrogen use efficiency, composting. So, sorry.
Great. My name's Jim Lyons. I'm a graduate of the school from a long time ago. But in the Clinton administration, I oversaw the Forest Service and NRCS and continue to work in that arena. And I guess one of the exciting things about what you're doing is obviously using natural systems to address climate mitigation. And I'm just curious what you need to do to further demonstrate this capacity, what kind of partnerships would be helpful. I own a 200-acre farm. It's probably not big enough to demonstrate what you want to demonstrate, but obviously we're going to have to look for different sources of revenue and income to make these investments. But having worked in the agriculture community, I think there's a great desire to find new technologies and new approaches farmers are slow to adopt these things, but I think the extent to which we're able to develop these demonstration projects, particularly, I think will accelerate that adaptation. Farmers depend on federal dollars for a lot of what they produce. And point earlier, that's going away. So the extent to which I think we can help them come up with alternative strategies to continue to increase production or at least maintain their operations will be critical. So this is a great time, my point, to bring this technology to the forefront and help people understand its application and utility, and I'd love to talk to you more about that.
Yeah, thanks for that. I think one of the things I would say from it is that there's a lot of change, obviously, in how federal agencies are interacting with universities, but agricultural subsidies are not going away. Agricultural subsidies are something in the US and worldwide that are a key part of how our food sector functions, and they are something that generally has bipartisan support. There's lots of critiques that could be moved towards those. There's lots of arguments of why they are not actually helping create a more stable and equitable food system, but it is something that I think we still do need to be wrestling with how we interact with. And some of the aspects of when interact with lawmakers, in most cases it's working with Republican lawmakers. In many cases it's the same thing as Mary was talking about with farmers. One of the things that, just on a very specific point of this, of how the conversation can resonate with a wide range of people, how it can become an essential part of US strategies. Many lawmakers are not interested in the carbon dioxide removal side of things, but they are interested in price stability in fertilizers. And as one thing that really affected our farm is the price of potassium tripled with the onset of the war in Ukraine. A large amount of potassium moves to Belarus. So there's been a strong interest thinking about how can we have different fertilizer sources that are domestically sourced. We don't have real supplies of phosphorus and potassium. We want to develop those. There's a huge interest in that the work that Mary's doing can help tie into, but doesn't have anything to do with carbon dioxide removal. So I think it's being flexible to how we frame our problems, and we're sticking with co-drivers. Thinking about how we can really present co-drivers in a way that is appealing to a wide range of people is something that is essential that we're going to have to do to be able to work with governments as they change, and have something where we don't have huge fluctuations in support as we do change, as the political winds shift.
And just more broadly, a lot of our geochemical work comes down to pH management, and people are going to continue to pay for pH management on farms and wastewater treatment systems. We haven't talked about the ocean today, but we're doing a lot of, except for the mangrove illusion, but we're doing a lot of work in marine environments. Ocean acidification, obviously a huge problem. It's affecting ecosystems, but it's also affecting livelihoods. It's affecting aquaculture, it's affecting commercial fisheries, and people are going to have to pay to mitigate that. So like leaning into these co-drivers, I think, is a path forward to kind of address the lack of willingness to pay for the carbon benefit of some of these interventions.
Right. Thank you. Finally, I get the mic. So I just wanted to comment a bit about the pushback on funding research in America, because I think it really presents a good opportunity. And I know we're excited about the agriculture sector, but I'm head sustainability in another industry that is very, very interesting, and I would like the center to pay attention to the cement and steel industry. And the reason is that I think research institutions in America haven't paid a lot of attention to the global research in the global south, and institutions in Europe have been doing a lot of that. And you would find out that cement industry has all these emissions. We still struggle to keep our emissions down to 600 kilograms per ton of cement, so that is a huge opportunity. Institutions like EPFL in Switzerland have been able to create solutions, and they have been deployed. One of the biggest limestone calcine clay factories is in Ghana, and the industry associations are scaling this solution. So back to the center. Just to challenge the center to look at industry associations, like the Cement Industry Association is called the GCCA. I represent my company in that association, and we are looking for solutions because we have committed to 2050, but technologies like carbon capture, utilization, and storage are gaining interest in Africa. IFC World Bank conducted a technoscoping, and there's a lot of opportunity in it, But there is the social and the business case, which I think that the natural carbon capture presents an advantage because there will be the skepticism of local people, land use concerns, security, and the rest of that. So I think there's a lot of opportunity for your research if you can look to the global south and look to industries like the cement and concrete sector, because we have lots of emissions there that we are trying to abate. Thank you.
First of all, we would love to talk about that, but Noah, do you want to talk a little bit about some of your work in the Global South?
Yeah, well, specifically on trials in the Global South and with cement industry, we actually have, I think, thinking about the upstream side of cement is absolutely essential, but also thinking about the end fate of cement. We have billions and billions of tons of cement waste that has the potential to remove carbon that is not being utilized right now. And we actually have field trials occurring in the Global South with one of our strong partners is a nonprofit called Mati Carbon that is utilizing the waste products of concrete. And would love to talk about that and love to talk about in terms of building trust. I think one of the things that academic centers can do is when there's funding for trials and those results can move out, that provides a first step of real scaling. Would love to continuing the discussion on cement. I think in many regions also it provides a way where there are not natural ways to regulate OPH. There's cement waste almost everywhere. So cement is something that is, of course, ubiquitous aspect of our life.
And not on this stage, but there are a number of folks at Yale who are working on decarbonizing cement. So that's obviously an opportunity. We've alluded to it, and Mary talked about basalt, but you can also use carbonates as feedstocks for all of these processes under certain conditions. And so there's a natural alliance with the cement industry in terms of the use of limestone. And so using the same feedstock, which can be used for enhanced weathering, Joe can use it in his process, and that's something that Pete Raymond is really, and Noah have been leading the research at Yale on that. So that's another thing we'd be super excited to talk about with folks. I think they have to set the room up for lunch, so maybe, I don't know, Ella, is there one more question, or? And we're happy to talk afterwards, too, and I'm sorry if we can't get to all the questions.
Hi, thanks, this is awesome. 2 questions, I'll make them short, but I'm curious for each of these technologies, what the maximum amount of greenhouse gas equivalents or CO2 equivalents actually is feasible when they're rolled out tomorrow versus kind of at their greatest reasonable potential scale. I know that, Mary, you mentioned the 50 to 60 gigatons per year emissions in society. I've heard we need like 10 gigatons per year to kind of stop our trajectory. And yeah, curious how these would actually get to that and like what their maximum is. And then also if we've figured out more of the tracking into, especially a lot of this will roll into ocean drawdown eventually, but are there new technologies out there for kind of understanding how much we're actually drawing down or predictive models and whatnot? Thanks so much.
Awesome. Those are great questions. Maybe Mary and Joe, do you want to talk a little bit about the scale potential of your solutions, and then Noah can maybe tackle the measurement question.
Great, I'll do a quick one. So enhanced rock weathering could capture multiple billions of tons a year, and I believe that the latest research is that that upper limit, that ceiling, may actually be dependent upon the carrying capacity and the efficiency of rivers. You basically take the CO2 that's in carbonic acid or rainwater, and it gets converted to something called bicarbonate, what limestone or seashells are made out of, that goes through the rivers and has to be efficiently transported through the rivers. If you've got an acidic river, not so useful, right? And then into the open ocean. And so some research shows that maybe the carrying capacity of those rivers is the key thing. So in America, we might be able to capture close to 1 billion tons a year, globally, multiple billions of tons a year. So there's still research going on, and a lot of that is led by the folks at Yale. And then on the ocean side, likewise, there's different efficiencies of permanent removal or permanent storage in the ocean. That depends sort of on where regionally in the marine world you come out from your river system. So there's active research, and Yale is actually at the forefront of a lot of that. Great question.
I'll keep it brief, which is just to say, part of what Noah was talking about and what we put into practice in our technologies is what we call, geochemical CDR or alkalinity-based CDR, which is like the biggest umbrella you can consider, which is you react CO2 with water and alkaline minerals to turn that CO2 into this more stable form of carbon, and then it's stored in the oceans for thousands of years. And if we think about the total CO2 fluxes that goes through Earth's water cycle, which is a core component of that reaction, it's as Mary pointed out, many, many billions of tons of CO2 every single year go through Earth's water cycle, whether that's soils, rivers, oceans, wastewater plants. So when we think about sort of potential using alkaline minerals to react CO2 and store it, it's very large. And that's, I think, what's so exciting about all the different approaches that are actually applying this at scale.
Yeah, well, I guess just one brief note on measurements. We're at time and going to lunch, so I think I'm going to punt on that to say that measurements are an essential aspect of moving forward, and I would love to chat about that. But I think the key aspect from this is that the main thing of where we're at right now is we're at a stage where we, without question, can track carbon fluxes. That's not the debate. The question is, how much does it cost? And what we're doing right now, which is the essential part, is taking really expensive techniques that academics love, that Pete and I have a lot of fun playing with, and comparing that to things that are actually financially operable. That's where we're at. That's the next step that matters. It's not, can we make measurements? It's, can we make measurements in a way that doesn't absolutely cripple a project?
2 quick editorial comments to close just in response to that question. Number 1, what we're talking about here on the stage is completely irrelevant if, as a global society, we don't reduce emissions by 90%. Carbon removals for that last mile of mitigation, so maybe 10% of emissions, which is going to be in that somewhere between 6 to 8 or 10 billion tons a year. No one solution is going to solve that problem, so we need a portfolio of solutions. That's what motivates the center's work. We work on forest carbon, we work on conventional regenerative agriculture, and then we work on these novel approaches. So we need a bunch of solutions to work, and that's what we're doing here at YCNCC. Thank you all. Sorry we ran over. Enjoy lunch. Great to meet you. Great to have you here, and look forward to talking.